Hello, this is Mrs. Ward, and I'm going to go over the 5.3, 5.4 review worksheet. So let's begin. The first ones are asking you to find all solutions to the equation. So the first one is 4 sine squared x minus 3. So remember, we're going to get the trig function on one side by itself before we start taking any square roots. So to do that, I'm going to add 3 to both sides. So 4 sine squared x is equal to 3. Divide both sides by 4. So sine squared x is equal to 3/4. Taking the square root, remember I square root this trig function, square root the numerator and the denominator. So I'm going to have the sine of x. Since I took the square root, it's going to be plus or minus. The square root of 3 I cannot simplify, but the square root of 4 is 2. So I have the sine of x is equal to plus or minus the square root of 3 over 2. I'm asking myself, when is the sine of x equal to the square root of 3 over 2? And that happens with anything with a denominator of 3. So that's going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Going back up, I check the directions. It wants all solutions, which means I'm going to add 2 and pi to those solutions because I'm going to go multiple wraps around my unit circle. Number 2 is 4 sine squared x minus sine squared x. Remember, I cannot divide by a trig function because I might eliminate one of my zeros, and I don't want to do that. So I am going to choose to subtract sine squared x from both sides. So I'm going to have 4 sine to the 4th x minus sine squared x is equal to 0. I'm going to choose to factor out a sine squared x and make that sine squared x times 4 sine squared x, because the sine squared times the sine squared will give me that sine to the 4th minus 1 is equal to 0. I'm going to use the zero product property and set both of these equal to 0. So I'm going to have sine squared x is equal to 0 and 4 sine squared x minus 1 is equal to 0. Here I'm going to take the square root of both sides, and I'm going to have the sine of x is equal to plus or minus 0 or just 0. And the sine of x is equal to 0 at 0, pi, and 2 pi. Then I'm going to just solve this one for, before I can take the square root, I want the signs to be on one side by itself. So I'm going to have 4 sine squared x is equal to 1 when I add 1 to both sides. Divide both sides by 4, taking the square root, square root, square root, square root. I'm going to have sine of x is equal to plus or minus. The square root of 1 is 1. The square root of 4 is 2. So plus or minus 1/2. And then I'm asking myself, when is the sine of x equal to 1/2? And that's going to be at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Going back and reading the directions for all solutions, I'm going to have to write the 2n pi for both of these. That's an n. All right. So that's the first ones. So the next ones is still find all the solutions. So again, leaving the trig function one side by itself. So I'm going to have 3 tangent of x is equal to the square root of 3 when I add the square root of 3 to both sides. Then I'm going to divide both sides by 3. And I'm going to have the tangent of x is equal to the square root of 3 over 3. And I'm asking myself, when is the tangent of x equal to the square root of 3 over 3? And that happens with anything with a denominator of 6, but it's positive, so this will be pi over 6. That's the one in the first quadrant. And the next time the tangent is positive is in the third quadrant, so that's going to be 7 pi over 6. It wants all solutions, so I'm going to add plus 2 and pi. The next one, I have 2 sine squared x minus sine x is equal to 1. Since I have that middle term or that linear term, I'm going to have to do product sum. So I'm going to bring everything on one side so I can set it to equal to 0. Remember, that's how we factor. And then my product is -2. My sum is -1. So I'm going to choose to use -2 and +1. And when I factor that, I am going to have 2 sine x plus 1, and then sine of x minus 1 is equal to 0. Set both of these equal to 0. So 2 sine x plus 1 is equal to 0. And then the sine of x minus 1 is equal to 0. Solving this one, I'm going to have 2 sine x is equal to -1. Sine of x is equal to -1/2. When is the sine of x equal to a -1/2? That's going to be with a denominator of 6, but in the third and fourth quadrant, so 7 pi over 6, 11 pi over 6. all solutions, so plus 2n pi. And then here I'm going to say sine of x is add 1 to both sides is equal to 1. And that happens at pi over 2 plus 2n pi. And you can lump all these together. You could write 7 pi over 6, 11 pi over 6, pi over 2, and then plus 2n pi. And that's the same thing as what I wrote. Either way is acceptable. The next one, find all the solutions in the interval of 0 to 2 pi, which means I'm not going to write the plus 2n pi at the end because I'm just going one lap around the unit circle. Number 5 is already factored for me, so I'm going to use the zero product property. I'm going to set both of those parentheses equal to 0. So when I do that, when is the cosine of x equal to 0? And that happens at pi over 2 and 3 pi over 2. This one, I'm going to subtract 1 from both sides, divide both sides by 2. So when is the cosine of x equal to negative 1/2? That's the denominator of 3. Happens in the second quadrant and the third quadrant. So that's going to be 2 pi over 3 and 4 pi over 3. And those are all my solutions, just these four, not adding any multiples of pi because I'm just in that one lap around the unit circle. So when I look at number 6, I notice that I have two trig functions. I have sine squared and I have cosine x. So in order to solve these, I have to be in one trig function. So the only one that I can change is the one that is squared. So the only one that I can rewrite is this sine squared x. So I'm going to rewrite sine squared x as 1 minus cosine squared x because that's using the Pythagorean identity. Everything else is going to stay the same. So this 2 will stay the same, equal to 2 plus cosine x will stay the same. So I'm going to distribute this 2, and I'm going to have 2 minus 2 cosine squared x is equal to 2 plus cosine x. So I'm going to add 2 cosine squared x to both sides, and I'm going to subtract 2 from both sides. And then subtract 2. And when I do that, I'm going to have 0 is equal to, putting it in descending order, 2 cosine squared x plus cosine x, and then the 2's will equal 0. So here I'm going to factor out a cosine of x. I'm going to have 2 cosine x plus 1. Using the zero product property, I'm going to set both of those equal to 0. And then I believe that's the same as this up here. Is it not? It is, but we'll go through it. Here, this will be pi over 2 and 3 pi over 2. Here, I'm going to subtract 1, divide by 2, and then this will be 2 pi over 3 and 4 pi over 3. And those are my solutions. Okay, the next one, again, I have two trig functions. I have secant squared x and tangent squared x, so I could pick either one. But the Pythagorean identity is 1 plus tangent squared x is equal to secant squared x. So I'm going to substitute this with 1 plus tangent squared x because that's using the Pythagorean identity. Everything else is going to stay the same. So when I distribute the 2, I'm going to have 2 plus the 2 tangent squared x plus tangent squared x minus 3 is equal to 0. So I'm going to have 3 tangent squared x, and then the 2 plus the negative 3 will be minus 1. So I'm going to have 3 tangent squared x is equal to 1. When I add 1 to both sides, divide both sides by 3. And now I'm going to take the square root. So square root, square root, square root. So I'm going to say the tangent of x is equal to plus or minus the square root of 1, which is 1, over the square root of 3. And then that's going to be anything with a denominator of 6. So it's going to be pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, and then I'm going to just go up here and make sure I'm just doing one lap around the unit circle, which I am, one lap around the unit circle. So these are all my answers. Okay, the next one, I am going to subtract tangent squared x from both sides. So when I do that, I'm going to have 3 tangent squared x minus 1 is equal to 0. Add 1 to both sides. divide both sides by 3, and then take the square root. So square root, whoopsie. Square root, square root. So I'm going to have the tangent of x is equal to plus or minus 1 over the square root of 3, which I could rationalize, not rationalize. It's still going to end up being these same answers, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So I hope you took the time to write the tangents on your unit circle so you have those quick and handy. The next one, cosecant squared x minus 4 cotangent squared x is equal to 1. Again, I have two different trig identities. I am going to go back and use the Pythagorean identity, which tells me that this cosecant is equal to 1 plus cotangent squared x minus 4 cotangent squared x is equal to 0. So I'm going to have 1 minus 3 cotangent squared x is equal to 0. It'd just be easier to take this over to the other side. So I'm going to have 1 is equal to 3 cotangent squared x. So cotangent squared x is equal to 1 over 3. Taking the square root of everything, I'm going to have plus or minus 1 over the square root of 3 is equal to the cotangent of x. Probably don't have the cotangent of x written on my unit circle, so I'm going to take the reciprocal, which would be the tangent of x. And so taking the reciprocal of this, I'm going to have plus or minus the square root of 3. So now I'm asking myself, when is the tangent equal to plus or minus the square root of 3? And that's going to be anything with a denominator of 3. So 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Going back and checking, this is just one lap around the unit circle. So one lap around the unit circle, and I am done. Okay, that finishes the 5-3 review. This is now 5-4. I'm going to use the sum and difference formula. So it has 75 degrees. So I'm going to separate 75 degrees. I chose to separate 75 degrees as 45 degrees plus 30 degrees. So when I go and do that, I'm going to say the sine of 75 degrees, because I'm going to do sine first, is equal to the sine of 45 degrees times the cosine of 30 degrees plus the cosine of 45 degrees sine of 30 degrees. That's just using the sum and difference formulas. Now the sine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2. Plus the cosine of 45 is the square root of 2 over 2. The sine of 30 degrees is 1/2. When I do this, I end up with the square root of 6 plus the square root of 2. Those are my numerators. And then 2 times 2 is 4. So this is all over 4. So that's the sine of 75 degrees. Now I'm going to do the cosine of 75 degrees. So now I'm using the sum formula for cosine. So to do that, I'm going to do the cosine of 45 degrees, cosine of 30 degrees, minus sine of 45 degrees, sine of 30 degrees. So to do that, that's going to be the square root of 2 over 2 times the square root of 3 over 2 minus the square root of 2 over 2 times 1/2. So when I multiply these numerators, it's the square root of 6 minus the square root of 2 all over 4. And that's equal to the cosine of 75 degrees. Okay, the next one, negative 225. So the way I thought of this is I thought of it as 45 degrees minus 270 degrees. So to do the sine of negative 225 degrees, I ended up doing the sine of 45, cosine of 270, minus cosine of 45, sine of 270. So when I do this, the sine of 45 is the square root of 2 over 2. The cosine of 270 degrees is 0, minus the cosine of 45, which is the square of 2 over 2, times the sine of 270 degrees, which is negative 1. So this first part will be 0, and then negative times negative would be a positive square root of 2 over 2. So my final answer is the square of 2 over 2. So at that point, I thought, well, that's actually an angle from my unit circle. Asked myself, well, what if I found the coterminal angle for negative 225? So I took negative 225, I added 360 to find one lap around the unit circle. When I did that, I got 135 degrees. 135 degrees is on my unit circle, and the sine of 135 degrees, if I look that up on my unit circle, is the square of 2 over 2. So this does match. But I'm going to go ahead and do the cosine so you can follow the work for the cosine too, using these two angles of 45 and 270. So the cosine of negative 225 degrees is equal to cosine of 45 degrees, cosine of 270 degrees, and now I'm going to switch that sign to a plus, and this will be sine 45, sine 270. So the cosine, this will be 4 square root of 2 over 2 times the cosine of 270, which is 0, plus the sine is square root of 2 over 2. The sine of negative 270 is negative 1. And this ends up being 0 minus the square root of 2 over 2, which is equal to negative square root of 2 over 2, which is the cosine of that 135. So that does match. Okay, moving on. The next one, find the exact value of the trigonometric expression given that the sine of u is equal to negative 8/17 and the cosine is equal to negative 3/5. So I'm going to take the time and I'm going to draw two triangles. This is going to be my u triangle. They're telling me that both u and v are in quadrant 3. So I'm going to draw a trig triangle on quadrant 3. This will be u. This will be v. Both triangles are in the third quadrant. U has a sine of negative 8/17, which means the opposite over the hypotenuse is negative 8/17. When I do Pythagorean theorem, I find out that this missing side is a negative 15, and it has to be negative because it's in the third quadrant. And then u and v, so the cosine of this angle, so the adjacent over the hypotenuse, negative 3/5, which means that this side here has to be a negative 4 when I do the Pythagorean theorem. So I have these two triangles for u and v. So now when I do the sine of u minus the sine of v, I like to take the time to actually write what I'm doing. So this will be the sine of u, cosine of v, minus cosine of u, sine of v. So that's just using the difference formula for sine, and now I'm going to find the bits and pieces and parts that I need to use. So the sine of u, this is u, the sine is negative 8/17. The cosine of v, so now I'm looking from this triangle here, v, cosine is negative 3/5, adjacent and hypotenuse. And then I'm going to have a minus sign. The cosine of u, so now I'm looking here, cosine would be negative 15/17, and the sine of v is negative 4/5. So when I multiply, I'm going to have 24 over 85 minus 60 over 85. So when I take 24 minus 60, I end up with a negative 36 over 85. And that's my answer. And just a real quick check, that number, since the sign has to be less than 1, between negative 1 and positive 1, which it is. All right, now I'm going to do the cosine of u plus v. So I'm going to do the same thing. I'm going to say cosine of u plus v. That's equal to the cosine of u times the cosine of v minus the sine of u, sine of v. So the cosine of u, looking from this triangle, negative 15/17. The cosine of v, looking from this triangle, negative 3/5, minus the sine of u, looking from this triangle, negative 8/17. And the sine, negative 4, whoopsie, that's a 4/5. So when I multiply, I'm going to get a positive 45 over 85, and then minus, and then positive 32 over 85, and when I subtract, I get 13 over 85, and that is my answer. So I think it's well worth the time to write this down so I know what I'm plugging in. Just personal opinion there. All right, so verify the identity. So to verify the identity, I'm actually going to work out the left side, and when I work out the left side, it should look like the right side. So I'm going to color code so you can see what I'm doing. The sign of x plus y, using the sum formula, that's going to be the sine of x cosine of y plus cosine of x sine of y. That's what this is equal to using the sum formula. And then here's that plus sign, so there's that plus sign. And now to do the sine of x minus y, that's going to be the sine of x cosine of y minus the cosine of x sine of y. And I'm trying to show that that's equal to 2 sine x cosine y. So when I look here, I have a sine of x cosine of y, and I have another cosine of x cosine of y. So I have two of them, 2 sine x cosine of y. Here I have a positive cosine x sine y, and I have a negative cosine x sine y. So those will equal 0. So now I've shown that I have 2 sine x y is equal to 2 cosine x cosine y. And so I verified that identity. But you have to show the work. The work is the problem. The next one, you want to verify this identity. So I'm going to do the same thing, color code again. So sine of x plus pi. So that's going to be the sine of x cosine of pi using the sum formula plus the cosine of x sine of pi. And then this is times. So I'm going to show multiplication here. And then now I'm going to do the sine of x minus pi. So this will be the sine of x cosine of pi minus cosine of x sine of pi. And I'm trying to show that that's equal to the sine squared x. So when I do this, this will be the sine of x, which will just say sine of x, times the cosine of pi, which is -1, plus the cosine of x times the sine of pi, which is 0. So when I do this, this will be negative sine of x plus 0. So I'm just going to write negative sine of x. Over here, I'm going to have sine of x times the cosine of pi, which is -1, minus cosine of x times the sine of pi, which is 0. And then the other side hasn't changed at all. So when I do this, this will be negative sine of x, and then this cosine of x times 0 will be 0, so this will just be negative sine of x. And I'm trying to show that that's equal to sine squared x. So here I'm going to have negative sine of x times negative sine of x, and negative times a negative will be positive. So I'll have sine squared x is equal to sine squared x. So I've verified the identity by working out the left side to make it look like the right side. The next one, you want to write the expression as sine or cosine of an angle. So I'm looking at my sum and difference formulas. I see here I have sine cosine. So as soon as I see that I have two different trig functions, I know I'm doing a sine formula because the sine formulas do sine cosine, cosine sine. The cosine formulas do cosine cosine, sine sine. So I know it's going to be sine. My two angles are 110 and 80 degrees. I just have to decide whether I'm adding them or subtracting them. When I look at my identity sheet, when I have the plus sign here, there's a plus sign here for sine. So this will end up being the sine of 190 degrees. I just add 110 plus 80. And that's it. I don't have to do anything else. It's just asking me to write it as an expression of sine or cosine. So this is my final answer. So looking at the next one, I have cosine, cosine, sine, sine. So since it's cosine, cosine, sine, sine, I know it's going to be a cosine identity, either sum or difference. My two angles are 0.96 and 0.42. A little odd looking, but it doesn't really matter. If there's a plus sign here, Then when I do this identity, there's a minus sign here. Those two signs switch. So now I'm going to take 0.96 minus 0.42 and get 0.54. So that will be the cosine of 0.54. And again, that's all they want me to do. And that's it. I'm done. So that is the review worksheet. I hope this helps, and we will see you next time.